Hello there. My name is Miss Raymore, welcoming you to A-Level Physics at Harris Academy, Beckenham. I'll be one of your physics teachers alongside Mr. Brown. Here at Harris Beckenham, we follow the AQA specification. This is divided into 7 topics and 1 optional topic, which for us is astrophysics. Along with this, we do 12 required practicals as stipulated by the exam board. Because A-Level Physics builds on the work done in GCSE Science and Mathematics, you will need to have a minimum of a grade 6 in Mathematics and a 7 in Combined Science or 6 in Separate Physics. As we follow the linear program, you will only be assessed formally at the end of the 2-year period. This will take the form of 3 papers, each being 2 hours long. Paper 1 will assess content covered in Year 1. Paper 2 will link Year 2 and Year 1 content. Paper 3 will be on practical techniques along with data analysis and 35 marks on the optional topic astrophysics. Assessment is an ongoing process here at Harris Beckenham. At the end of each assessment period, students will be given an achievement, a target, and then a student action that they will need to complete to help them achieve their target that was stipulated. This is shown on your screen. For practical assessments, they are done independently in most cases. While students work, teachers will assess them based on the criteria that was given by the exam board. Once done, these will be recorded in their lab books, which we will provide. Here on your screen is an example of work done by one of our Year 12 students. In this practical, they're investigating acceleration due to gravity using the free fall method. Why physics, you ask? Studying A-level physics can lead to many exciting careers, such as a secondary school teacher, an engineer, a doctor, a research scientist, a patent attorney, or even a science writer. Thank you for joining us and thank you for listening. I'm looking forward to seeing you in September.
So good morning, my name is Mr. Brown. I'm here to introduce A-Level Physics at Harris Beckenham. In order to complete this course, you will definitely need to have a 6 in math and a 6 in science. And today I'm going to introduce you to one of our practicals. It's about the current balance measuring flux density. Alright, so today basically what you need to do is just to measure the flux density between 2 magnets. You'll realize that these magnets are not labeled, so I went ahead before and labeled that this is a south pole and such. We have our wire, which is our current carrying conductor, power pack, which is connected to an ammeter. I can measure the current that is flowing through this wire using the ammeter, and then to control the amount of current that flows through the wire, I can use a variable resistor. To start off the practical, I zero my balance just to ensure that all the weight is 0. Switch on my ammeter. Ensure that my wire is in between the magnets. Just want to get it a little bit higher. Alright, that's good. And what we will do now, just to remember that this principle uses the strength, the force that is provided by the magnetic field. So F is equal to BIL. So force is what the magnetic field is going to bring. We need to measure this, which is the flux density. I is the current from the ammeter, and L is just the length between the magnets. Alright, so I can get the force, which is mass times gravity, so the mass will be coming from the balance. So let's switch on. So when I switch on, my first reading is 0.48 on ammeter, 0.22 grams. I can convert that to kilograms, get my mass in kilograms, multiply that by gravity, which is 9.81 for A levels, no longer 10.